and I'll share my screen, and I'll put this one up. So can you see that, the process so far?
Yes.
Right. So I think you've all seen this. It's been issued to you. And I'll send another one out to say what's next. I'll tell you what's next when we finish anyway, but I've highlighted a few things here. This is something that I've always remembered right through my whole career, is that everything we do is a process. Okay, so that I get that into my tiny little brain, and I try to remember that work through the process. It makes life a bit easier for you. Design and construction program we talked about earlier. This is really important to be aware of what the program is. So when you're designing things and when you go into construction, the builder will always have a program, and that becomes the driving document for the project, that you have to comply with that. If you don't, there can be severe penalties. And then I've highlighted workshop drawings, which we talked about a few weeks ago. So that'll be relevant to the discussion today. Getting the drawings completed, getting them approved, and getting ready for construction. So here are the notes. So I've added a few things to just to have a discussion. I'm open to questions at any time. And so we're talking about manufacture and installation or construction phase. Now, I've thought of a few words that start with C, which are really important. Construction, obviously. Coordination. You're all aware of coordination in design. Coordination in construction is equally important. We all have to work together on site. Cooperation, communication, collaboration, clash detection. Clash detection is normally done in the drafting phase, but surprise, surprise, sometimes things don't work out on site. That things still clash, and it happens in every job. I don't think there'd be any job where you can build a job straight off the drawings because the builder builds something differently, or somebody changes their design and forgets to tell someone or doesn't want to tell someone. It always happens. So just be ready for that to happen, and we have to react to that and potentially make changes to our work to suit the change on site. So when all of the equipment has been approved, and I say where applicable because if it's a design and construct project, there may not be an approving authority. So it's up to the contractor to be satisfied that the equipment is what's required. The equipment can be manufactured and or delivered to site for installation. So I've mentioned a few types of projects here that we get involved in. Construct only is where a consultant produces a set of documents. So the MOTMAC guys, or this is normally what you do, you produce a set of documents that contractors tender. And then the contract may be either construct only, which means we comply or contractors comply basically to the letter of your documents, or it may be a design and construct where your documents are used as a guide, and there's some flexibility to change things if necessary, and the builder will always push for value management. Now, I'm sure, or value engineering. I'm sure have you heard that term? Value management? Okay, well, that's a fancy word for try and save some money. And there's always ways of doing that. And so the job may become design and construct, where the responsibility for the design rests with the mechanical contractor. Fast track is another term that may not be used so much these days, but it still sort of works that way, that the client or the builder or developer decides that instead of building this job in 12 months, we want to do it in 6 months. And so how can we do that? we all pull our hair out and we do everything we can to try and get it built quickly. Now, this is a bit dangerous too, so you've got to be careful, because if you build something too quickly, there's going to be errors probably. So try and avoid getting involved in that sort of thing. But really, the projects are driven by the builders, so we haven't got much choice. If they want that, we usually have to do it. Now, I've mentioned construction staging as well. Some projects are built in various stages. I worked on a hospital project in Sydney a few years ago where it was an existing hospital, but they were building a new hospital within the grounds of the existing hospital and interfacing that with existing buildings. So it was sort of built in the middle of an existing building. So apart from there being a new building involved, there was interfacing with the existing, upgrading the existing. So the new building was built first, then upgrades to the existing were built, and obviously decanting of people from one department to another was going on as we work through the construction. So that gets quite complicated, but that's another thing that you'll come across. When the shop drawings are approved for construction, the ductwork can be manufactured and delivered to site for installation. The drawings are prepared in accordance with the design and construction program or the building program. So I'm talking about contracting again here, where shop drawings are involved. It's really important to produce a drawing program which is in line with the construction program. And on a project where you might have 100 drawings or 200 drawings, they've got to be produced in sequence to keep up with the building. Delivery to site of equipment and ductwork is carried out in sequence to suit the building program. Once again, it's all driven by the building program. When do we need this equipment on site? When do we need the ductwork? Make sure it's there in time to be installed in accordance with the building program, because the builder won't wait for anyone. If you haven't got your equipment and ductwork there and pipe work and everything else that goes into it, they're not going to wait for you. They'll just keep going. So there's a chance that you'll get built out. Builders will also do funny things sometimes. Like I can remember a project years or decades ago, actually, but it was a very big project. We were installing chillers in the basement level, and the builder wanted to build walls. So he kept building this wall. I think he built it, say, twice probably. He built it once, and we said, look, sorry, but we need that access way to get the chillers in. Oh, okay. So we had a bit of an argument. He knocked the wall down. And then, so we're still waiting for the chillers to arrive on site. He built the wall again. He said, we still need to get through there. We need the access. So he knocked the wall down again. I mean, that's a bit of a silly thing to do, but these sort of things go on, that they just want to keep building. And most of for the smaller projects, most of the ductwork, pipe work, equipment is in the ceiling space. Okay? They'll want to put their ceilings in as soon as they can. So got to make sure that everything's in the ceiling before they build the ceilings, because otherwise they'll be pulling ceilings down and somebody's got to pay for that. So it's being aware of the program, and going back to these C's up here: communication, coordination, all of these things are really important. Keep talking to the builder, understand what the program is, make sure that you get things done on time. And delivery to site of equipment and ductwork, I'm talking about, that's important. It's like a just-in-time process. The ductwork that's manufactured in the factories, they have limited storage space. They can't make all the ductwork for a job and store it in the factory because there's no room for that. They've got to do it in sequence with the building program. So there becomes a number of programs. There's the builder's program, which is the overriding program for the whole project. there'll be a mechanical services construction program, which sets out the overall mechanical, just the mechanical work. And there's a drafting program. There'll be an engineering program. Now, I don't know whether our consulting friends have design programs. I imagine you would have something that tells you, this is the phase that you've got to get to 30% or 50% or 70%. And it's all important. It all ties in with trying to get the project built on time, basically. Now, I've also mentioned rough-in and fit-off stages. The rough-in stage is work basically that's above ceilings. So getting in ductwork above ceilings, pipe work, equipment, wiring, everything associated with mechanical services is being rough-in is probably not a good word because it's not that rough. It's got to be put in properly and it's got to be put in accurately. But it gets it in above the ceilings. Then the builder can come along and get the ceilings installed, which he's always keen to do. And the ceiling contractors are chomping at the bit, wanting to get started. So once that's all done, then you go to the fit-off stage, which is the work below the ceiling. So putting in air outlets, grills, temperature sensors, all of the stuff that you can see when it's finished. So once the equipment and ductwork are on site, they're installed in locations coordinated with all the other building services and features. And hopefully most of this is sorted out during the design phase. But as I said, it's not always the case, and some things on site occur. I can remember one job that was in Sydney. There was a plant room with some big chillers, and it was basically just a mechanical plant room. There was nothing else going in there. But the plumber, the hydraulics contractor, had to get a very big pipe across that area somehow. So he decided he'd get in early, and it was about a 300 diameter pipe. He ran it straight through the middle of the plant room where the chillers had to go. And it was a big job for him. It cost him a lot of money to install it. We came along to site and said, "What's this pipe doing here?" Spoke to him, and he said, "Well, okay, I just wanted to get in early." And I said, "Well, you can't put it there because that's where our chillers go." So he had to pull it all out and put it somewhere else. So, these things happen. You've got to be prepared to talk to the contractors if they do things incorrectly and say, "Look, you can't do that. It doesn't go there. You'll have to put it somewhere else." So I've said here, site coordination and changes are inevitable, despite the best efforts to avoid clashes during the drafting phase. So be prepared for that. Things change, and the design can change. Another project I worked on, the builder had decided in their wisdom that they could buy cheaper glass than what was specified. So the design had been done based on a certain type of glazing which had a very good U value and shading coefficient, and they decided they could buy a cheaper one from some place in the world that would save them probably hundreds of thousands of dollars. And so everyone can guess what happens if you change the glass. So you go back to the start changing your heat loads again. It was right at a critical time in the project to make a major change like that. Sent everyone into a frenzy. Anyway, we got through it. We had to redo the calculations. We had to change the equipment. Some of the equipment was already on site. So we had to change all that. We tried to shuffle it. We had air handling units. We tried to shuffle air handling units around where we could. It just creates mayhem. But sometimes these things happen. So be ready for change. Change is inevitable. And then the wiring of the equipment and controls is carried out sequentially after the equipment is installed. So all these things are happening at the same time. The equipment's going in, the electricians are on site, the controls contractors are on site, they're all running their wires. So there's a lot of coordination and cooperation required to get things done properly. Okay. And the installation process continues until all of the equipment, ductwork, pipework, wiring controls, etc., are installed and ready for testing. So once it's all in, we're ready to start commissioning, which we won't talk about today. We'll talk about that next week. But I've got a few points here to talk about. Beware of site measures. Now, site measures are usually inevitable as well. And this, I'm talking really from the contracting side again now. Site measures is where something on site doesn't fit. Okay, so the drawings have been done. Let's say it's a fan coil unit with ductwork, and when they installed it on site, they weren't able to put it in the same place that it was shown on the drawings for some reason. Somebody else had put the pipe there or something. And so we've agreed on site that we'll move the fan coil unit. But that probably means we're going to change the ductwork. Okay, so instead of having a nice straight flow out of the fan coil unit, suddenly we've got this horrible looking transition that comes off the front of the fan coil unit so we can get the ductwork back to where it has to be. You understand what I mean? And that can be disastrous for the airflow. But it might be a fan. I'll give you an example of one job that I was in. No, I wasn't involved in it, but I was called in to try and help them solve it. It was a shopping centre. We had a long run of ventilation ductwork and quite a big duct. And the builder, we had to have a penetration through a concrete wall somewhere in the project, and the builder decided that he couldn't put a penetration that size, so he put a small one in. And then he said, well, you have to get your duct through that hole. And we said, well, it's not big enough. He said, well, I'm not making it any bigger. I can't make it bigger, so you have to do that. So on site, our guys didn't ask the engineering team. They just went ahead and made this transition. And let's say it was a metre square. They made a transition to 500 square to get through this hole and then back out to a metre square. Now, can you imagine what that does to your fan? That's a nasty restriction and a very high velocity through that point. And guess what? The fan didn't work, or it didn't deliver the airflow that was required. And it turned out that the problem was this restriction. So they said to me, what are we going to do about it? And I said, well, you have to tell the builder to make the hole bigger. We put the proper duct in. I said, oh, I can't do that. He said, well, you have to. Otherwise, it's never going to work. You can upgrade the fan potentially to cater for the additional pressure, but then you've got noise problems, your power consumption goes up. So all these things, it's like a snowball. You know, you have more problems. So I'm rambling on, but these things can happen. So, but with site measures, in a place where I used to work, we had a policy that if any site measures were required, they would have to go through engineering first before they were allowed to be made in the factory. Quite often what happens is a site person will send a sketch straight to the factory, get it made, sent to site, and they install it. And the first thing you hear about it is something's not working properly, or it's noisy, or, you know, we can't get the airflow. And when you look at it, oh, that's different to what we designed. So just be wary of it. Try and inspect site work progressively. You know, you have guys on site in the mechanical team who are doing the very best they can. Everyone's trying to do a good job, but they can make mistakes. They're only human, and they can make decisions sometimes without discussing with other people, and which can cause problems. So if the engineers can get to site, have a walk around the site, and you don't have to go through things with a fine-tooth comb, but just have a general look around and see if things look okay. And I would say in my career, every time I've been to site, and with no exceptions, I've found something that wasn't right. Just by having a look, and then you talk to the guys on site and say, listen, guys, there's a problem here, and they'll be happy to fix it. And you've got to remember the guys on site are under a lot of pressure from the builder as well. They're getting hammered to get everything installed, and they do it as quickly as they can, but sometimes mistakes can be made. So the other thing, sorry, an important thing is, it's all important, but particularly important are the fire safety features, such as fire dampers. Make sure they're installed correctly. Penetration through firewalls with pipe work. There are requirements for the way pipes are insulated through firewalls. Make sure that's all done correctly, because that can come back to bite you later. So I know it's a bit difficult. You're in your offices and you don't get out much, but talk to your managers and ask them to give you the opportunity to go to site and see what's happening out there, and get a feel for how things are done. And if you go out there as often as you can, seeing the work on site gives you a greater insight into the work you're doing. I can remember when I started work, first time I went to site, I was amazed. I was looking at things and saying, oh, is that what a piece of duct actually looks like? Is that what a pipe looks like? And then I took a young engineer in Brisbane one time. We were doing a hospital project and he'd never been to site. So I took him out for a site visit, and he was like me that first time I went to site. His eyes just opened up, and that was a big project. We had a lot of air handling units, chillers, pumps, boilers, the whole works. And he was fascinated with it. And you can sit at a desk and do your design without really knowing what you're dealing with. So it's good to get out and have a look. If you do see something that's not correct, don't be afraid to speak up. Speak to the site manager, preferably, or the project manager. Generally, the site manager will be based on site. He'll be there all the time. The project manager may not be, but he needs to know as well. And get it fixed. Don't be afraid to speak up, because they're not going to bite your head off. If you just say to them, look, I don't think this is correct. Can we check it? Okay, let's have a look. Fix it. If it's not right, fix it before it becomes a problem. The same thing goes for, and this is a tough one, but it's really important. Even if they're not part of the mechanical team, if they're part of another team, if you see something on site that's not right, or somebody is doing something that's not right and may not be safe, say something to them. Say, hey, mate, what you're doing is not safe, or it's not right. Don't do it. It's easy to say, not easy to do. But one of our managers had a good saying. He said, if you walk past something that's not right, you've accepted it. So if you're aware that it's not right and you don't say anything, then you're part of the problem if it's a problem later on, or if someone gets hurt. We had a fellow in Sydney, site manager, terrific guy. He was actually a builder by trade, but he joined us because he wanted to get involved in mechanical services and learn more about building services generally. And so he knew a lot about the building trade. And he became very popular on site, even with the builders, because he used to tell the builders what they were doing wrong. And usually the builders don't like that, but they respected it, because he was mainly concerned about safety. That the builder was doing things that weren't safe. And our guy was very quick to stand up and speak to them and say, what you're doing is not safe. You need to do it differently. And so safety is really important. Safety, is probably number one thing you've got to think about whatever you're doing, whether you're in the office or on site or playing sport, or whatever else. I suppose playing sport, you're not always thinking about safety, but you're just going hard to do what you've got to do. But stay safe and be aware of the site safety rules. You got to wear PPE, you got to wear your boots and hats and helmets. You might have to wear gloves on some sites. Um, some sites even have rules about what you wear. So for the men, you may not be able to wear shorts. You might have to wear long pants on site, and long sleeve shirts and gloves and goggles and all these things. Be aware of what's required. Don't turn up to site with all that without those things or without knowing what's required, because you won't get one step onto the site. They'll turn you around and send you back. It's all about your own safety. So, as I said, try to visit the site as often as you can. As seeing the work on site gives you a much greater insight into what you're doing. So that's a fairly brief run through. It's a big topic again, but just wanted to highlight a few things there. And as I said, safety is number one. Any questions?
I've got a question.
Yep.
There is a design error that happens to not be picked up until it has been constructed. What's the process that's involved with determining where that cost will be covered by?
Yeah, good question. So the design error hasn't been picked up and you've gone right through construction and commissioned it, and then you've suddenly realised that, let's say, you haven't got enough capacity in your air conditioning system, something like that.
Yeah.
Is that what you? Yeah.
Mm-hmm.
So there'll be a big argument about that if it doesn't work. Firstly, there'll be a lot of finger pointing, but it's really everyone needs to work together and work out what the problem is. If it turns out that the calculations were not correct initially, then it may be the designers. I won't say the consultant, because they're not necessarily the ones who designed it. It's the designer's responsibility to correct that, and whoever the designer is may have the responsibility to pay for the ramifications of that error. But then the question is, well, why was that error made? Was incorrect information made available? Was the design criteria incorrect that was given to the designer? So you need to work back and find what's the root cause of that error. If it's just let's say it's just an error in the input of the data, and the heat load comes out at 50 kilowatts and it should have been 100, then it's the designer who probably has to pay for that at the end of the day. Does that answer the question?
Yeah, thanks.
It gets a bit grey, because everyone will be trying to find a reason as to why that mistake was made, but it comes back to checks and balances, I guess, that who's checking the work that's been done. There should always be a system of review, so that the person who did it has done their job, but who has reviewed it? Has someone had a look over those calculations and made sure that it's correct? So if you have those checks and balances all the way through, then hopefully that won't happen. I had a project, this one was in Queensland years ago. It was a resort. Excuse me a sec. And I had a young engineer assisting me, and who did the calculations, did the heat loads. And it was quite a big project, and it took a while to get the heat loads done. But the engineer brought them back to me and put them in front of me and said, "Can we go through these?" And I said, "Yep." So I looked at it for about a minute and I said, "It's wrong." And it was, the engineer looked at me and said, "What do you mean it's wrong?" I said, "Well, I don't believe it's right." "Why?" "Well, the front page of the Camel output gives you watts per square metre, litres a second per square metre, etc., etc. Now, you'd all be familiar with that. You've done heat loads. watts per square metre for this project was 1,000. That was what the calculation said. And I said, well, it can't possibly be 1,000 watts a square metre. Why not? And I said, it won't be. I said, it'll be something like 150 watts a square metre. Oh, how do you know that? Well, you know, after you've been doing this for a while, you get to get a feel for what the load is likely to be. And Aero Guides, the Aero Technical Manual, has a sheet, has a page in there that gives you a rough idea of what to expect. Like a shopping centre might be 350 watts a square metre. An office building might be 125 or something like that. And a resort, I thought, well, 150, it's not going to be 1,000. So I said to the young engineer, just go away. There's something wrong with your input. Just go and see if you can find it. Well, he came back to me. He said, oh, I think I found it. I had 100 watts a square metre for lighting all through the whole place, or something like that. I can't remember exactly what the numbers were, but it doesn't matter. So changed the input, came back, we got the right answer. So these are things that if you're not, if you haven't got someone reviewing the work, this can go through the system and can become a problem. So checking, get someone else to have a look at it. I'm sure you guys in the consulting fraternity would go past your more senior engineers to have a look, or someone who's, you know, sort of supervising the project. It's basically quality assurance, you know, and that's another big subject of having the checks and balances in place to make sure that errors are at least minimised, and certainly major errors, which can cost money. Any other questions?
I've got a question actually. One more.
Yep.
I've
sure.
got one more question.
Yep.
What about if it's already completed construction and then the end users complained and said that conditions are not comfortable? How would you then quantify what comfortable is? Because like the Australian standards doesn't explicitly say what's required for comfort conditions, and it's quite subjective to opinion. And I guess as an example,
exactly.
what if you have like, because you can't, there's a limited amount of outside air you can connect to a cassette unit, and then the contractor might decide to put that outside air into the room separate from the cassette unit, and then they just decided to use an egg crate grill rather than an actual diffuser to save on costs. And like technically it's compliant because we've got sufficient amount of outside air, but because they're using an egg crate grill and there's not sufficient air diffusion, then the end user would complain that it's not comfortable. Then what happens then?
Well, anything can happen. I guess if they haven't, if the installer hasn't complied with the agreed design, the approved design, then they're responsible to fix it. So if they were supposed to take the outside air through the fan coil unit to pre-cool it, or it was supposed to be, if it's not pre-cooled and it goes through a diffuser, but they put an egg crate grill, they have to change it. It's got to be fixed properly. As far as comfort conditions go, ERA also talks about that, or ASHRAE talks about a range of comfort conditions. But the thing that is important is that every project should have design criteria. And, excuse me, the design criteria sets out what the agreed conditions are going to be for that project. So the design calculations are based on the criteria, and that's what we're trying to achieve. So if let's say the design was based on 23 degrees and we can only achieve 25, we need to find out why that happened. If it turns out that the equipment that we put in is not performing as required, we can replace it. we can do some sort of, well, obviously there'll be a lot of talking going on, come up with some sort of acceptance deal where the client may say, well, look, okay, we're going to accept 25 degrees, but you haven't given us what we asked for, so we're going to sue you. And this can happen. Or give us $50,000, for instance, and we'll forget about it. All sorts of things can happen. It's really just about discussing it, how we're going to resolve it. But the client can say, I won't accept it until you get it right, which means the contractor needs to understand what they did wrong, fix it, and get it to be the way it should be. It's a good question because that does happen quite a bit, where certain zones, say in an office building, perimeter zones may not be achieving the design conditions because maybe during the calculation process, they got the angle of the building wrong or something, and the solar load is greater than they expected it to be, and maybe it comes back, like I said before, maybe it turns out that the glass is the wrong glass. So you need to look through all that and find out what's the root cause of the problem. But yeah, that's quite a common thing to not be able to achieve the design conditions for whatever reason, and need to understand the reason, and then the responsible person has to fix it, basically. Does that answer your question?
Yep, thanks.
There's no black and white, unfortunately. But I mean, if you develop good relationships with everyone involved in the project, these things can usually be worked out. There might be a lot of shouting and banging tables and carrying on, but you just need to get back to, okay, what's happened? Why have we gone wrong? Determine that, and then go about getting it fixed or coming up with some agreement on how to move on. Okay. Anything else? No? Okay. Well, we'll finish there. Next week, we're going to go on to testing and commissioning. So once all the construction is finished, we start to test everything. We're getting to the really pointy end of the project now because with all the good work that's been done with the design and the drafting and the installation, this comes back to your question, Stephen, if it doesn't work, we're in trouble. So testing and commissioning is extremely important to get it all working properly. And this can go on for 12 months, until everyone's satisfied that it works properly. So we'll talk about that in a bit more detail next week. Okay. Thanks for coming. And thanks for the question.